Once again, pause the video right now and try to solve it yourself. All right, welcome back. This is another conservation of question, like the one from yesterday, except this one also has non-conservative force doing work. The non-conservative force here is friction. So we apply the conservation of energy equation, which says that the change in mechanical energy is equal to the work done by non-conservative force. We notice that the initial mechanical energy is equal to spring potential energy, and the final mechanical energy is equal to gravitational potential energy. So plugging in the equations, change in mechanical energy is going to be final minus initial, which is mgh minus 1/2 kx squared. Work done by friction is F friction force times displacement times cosine the angle between them, 180 degrees, since you're sliding up the ramp with friction pointing down the ramp. All right, so I'm not going to fill out the entire solution because it's a lot of numbers, but two things to be careful of. Right now we have two unknowns, H and D. That's a problem. However, we can notice that the unknown H can be replaced with a function of D, and that is going to be D times sine 25 degrees. Simple trigonometry. Another thing to be careful about is the friction force, which is coefficient of friction times normal force, and the normal force here is not mass times g. However, it is mg cosine 25 degrees. It's because the y component of force of gravity is equal to the normal force, not the force of gravity itself being equal to normal force. Once you have all the numbers plugged in, you should get your displacement as around 1.46 meters.